Welcome to this webinar on post-fire food safety, which provides an overview of how wildfire impacts the health and safety of locally grown produce and backyard chicken eggs from home, school, and community gardens and local farms. This webinar draws on two University of California studies done after wildfire spread through Sonoma County and the state in the fall of 2017. Together, the joint studies sought to find out if garden and farm-grown produce and backyard chicken eggs exposed to ash were safe to eat, mobilize the community in the days and weeks after the fire to collect leafy greens from sites across the county and backyard chicken eggs from across the state for later analysis, formed a unique partnership between the university and community researchers, and ultimately led to a workshop series, a scientific report, and a toolkit for other communities affected by wildfire to assess the safety of their own unique context. By the end of this webinar, we hope you will understand the potential risk of contamination for produce and eggs within the larger context of cumulative risk of exposure, environmental health, and the benefits of a resilient local food system. Increase your knowledge of air pollution and environmental health, including how toxins spread through smoke and ash and how they can impact other parts of the environment. And understand how to identify potential exposures, reduce community and individual risks, and increase protective factors during and after wildfire events, as well as day-to-day. This webinar is intended for residents of Sonoma County, as well as residents of other communities affected by wildfire, particularly urban wildfire, as well as government officials working in agriculture, public health, and environmental health, school, community, and home gardeners, local farmers, farm workers, and ag support organizations, and environmental justice and community food security advocates. Our presenters today include myself, Julia Van Solden Kim, a UC Cooperative Extension Food Systems Advisor with a background in public health and community food security. Vanessa Raditz, a science coordinator for the post-fire produce safety study with a background in urban farming and environmental health. Todd Kelman, a veterinarian and UC Davis researcher with the post-fire egg safety study. And Rob Benetton, a UC Cooperative Extension Bay Area urban agriculture advisor with a background in urban soil quality. In this webinar, we will be covering urban wildfire environmental health and risk assessment, the methods and results from our plant and soil samples, the methods and results from our backyard chicken egg samples, the methods and results from our cumulative risk assessment, and best practices for reducing risk and resources for additional information. Before we move on to our other presenters, I want to note that all of our sites in our study are confidential and clarify that the data presented today do not represent sites that were burned or directly adjacent to burned buildings. Now, I would like to welcome Vanessa Raditz to provide some additional background and context.
Thank you, Julia. So my name is Vanessa Raditz, and I joined this study as a interested community member who was doing community response work following the fires that impacted Santa Rosa in the fall of 2017. And there was a very consistent concern from a number of the people that were helping to move local produce to the kitchens and evacuation shelters. And that concern was, is the smoke from this fire, the smoke being all of the burned buildings, all of the belongings in those homes, all of the cars, is the smoke from that fire impacting the food that we're now serving to people who have been evacuated? And based on my experience of looking into these questions in urban agriculture, I decided that this question was worth it for us to explore and get some answers to the people who were giving so much of their time and energy for the local response. Now, about 2 years later, we do have some data. This is some information from UC Davis, from a study coming from their environmental health team, showing that, in fact, it's not just anecdotal. About a quarter of Sonoma County residents that were surveyed last year, from January to December of 2018, a quarter of them are concerned about the safety of locally grown produce due to fire. And while the fires of 2017 are no longer the most pressing concern, we do know that we live in a wildfire ecology here in California. And so these concerns are going to come up time and time again. And hopefully the information that we have now from 2017 will help you in responding to the next wildfires that come. So to begin, we do know that smoke carries chemicals. And when it came to this particular fire, the smoke was spreading those chemicals through the air over a very wide region. On the right, you can see a time-lapse map of the distribution of smoke. When you see the dark yellow, those are the hotspot areas that had the highest level. So we know that our region here in Sonoma County was highly impacted. We also know through studies in urban agriculture that these chemicals do not stay just in the smoke. So this is a hypothetical model that's based on a number of different studies showing the multiple different ways that the chemicals that are in the air pollution are then transported throughout the environment, through the soil, into the water, and into the plants. Humans can then be exposed to these chemicals in a number of different ways. Humans can inhale the chemicals directly from the smoke, and this is one of the most dangerous ways because it goes directly into your lungs, which are a very sensitive tissue. However, we also know that it is possible to ingest these chemicals once they've moved into plant tissue. It's also possible to absorb some chemicals through your skin. So touching and interacting with soil itself can be a way that some chemicals can get into the body. So knowing that there are so many different chemicals that can exist in the smoke after an urban wildfire, we had to narrow down what we were going to look for in our studies. So for the produce safety project that I have been working on, this project started from concerns from the community. And so we used those particular concerns to choose some of the chemicals we looked for, including dioxins. We also used these previous studies from urban agriculture to understand which are some of the chronic air pollutants that are documented that we could be looking for after a wildfire. And then last, and of great importance, there was a letter from the FDA written to the California Department of Food and Agriculture detailing from their perspective as a government agency some of the chemicals that they recommended California look into because they were most likely to be of concern. We've also been in partnership with another study that is working on backyard chicken eggs. And for their study, they were similarly coming to the understanding and the awareness that chickens as ground feeders are going to be exposed to the deposits from the contaminants in smoke. And so they looked at previous studies that identified lead in eggs as an issue from foraging birds, as well as other studies that found a variety of other toxins in ash from urban wildfire that chickens could be exposed to. And with that, I'd like to introduce Todd Kelman, who has been working with us as we've merged the results from the Produce Safety Project and this backyard chicken egg study.
All right, thanks so much, Vanessa. This is Todd Kelman with UC Davis. So the next question is, what exactly is it that we analyze? The first group of chemicals is the thing that you're going to have the most familiarity with, most likely. It's heavy metals. It's things like lead and cadmium and mercury and arsenic. It's things that are naturally in the environment, but can be emitted in increased toxic levels from industrial activities, like from a lead smelting plant, or think about all the heavy metals that might be in your computer or your electronics and your cars, and what would happen in the case of urban wildfire. Things are burning, you're going to have a release of these chemicals in much larger amounts than usual. And they can be carcinogenic, toxic to a variety of organ systems, cause developmental effects on both fetuses and children. The next class of compounds are the polycyclic aromatic hydrocarbons. You might not have heard of those by name, but you certainly are familiar with those, at least by sight and taste. It's the char on the food that's so good. It's also can come from traffic-related air pollution and like we mentioned, can enter the diet through grilling and drying and smoking foods. We thought that they really were primarily a long-term concern, a cancer concern. We're learning more and more about what their acute effects, their short-term effects might be, including on reproductive health. Now, this next group, all three of these fall into a category that we call persistent organic pollutants. And basically, that's just a way to say that they hang around in the environment for a long time. Some of these chemicals haven't been used for decades, but they're still of concern because they exist in the environment for so long. They persist. You know, the first in this class are the dioxins and furans that are basically industrial byproducts, but they're also produced from combustion, burning of waste, can be hospital waste or typical home waste, from fuel burning, and from urban wildfire. Their toxic effects are widespread on the immune system, on development, on hormones, what we call the endocrine system, and they can also cause cancer. Now, the PCBs, those are the ones that haven't been used since the 70s, but they still exist. They're still around. They are used as coolants and lubricants. They're in things like transformers, electrical transformers. So you can imagine in urban wildfire causing the disruption of the integrity of a transformer is going to leak these into the environment. And they're associated with disruption of the development of the nervous system, of the endocrine system. They can cause liver cancer. And then the last group are what we call the PBDEs. These are fire flame retardants. Now, these are not the flame retardants that you see firefighters using to battle wildfire. They're not the things dropped from tankers. These are things that are in foam furniture, plastics, clothing, electronics. In the United States, two of the big classes of these compounds were actually withdrawn voluntarily in 2004 due to health concerns, and all have been phased out by 2013, but they persist. And again, an urban wildfire can cause breakdown and release of these compounds in much greater concentrations. And these are also known endocrine disruptors. They can disrupt the hormone signaling in the body and can cause liver and problems with development of the nervous system. So the next question is, well, how do you determine what is safe and what is unsafe? We already said that some of these things like heavy metals already exist in the environment. They're natural substances. And there's more to it than just saying the dose makes the toxin. So there's issues of how long do these things persist in the body? Do they persist in the body a long time, or are they excreted quickly? There is how long are you exposed for? Is it a chronic exposure, more than 3 months? Is it a short exposure? You would think with smoke, maybe a short acute exposure or subacute exposure. However, what if these things from the smoke and ash get into the soil and exist for a long time? Then you're looking at more of a chronic exposure. And then there are the things that we don't think very commonly about, sort of the personal context, the vulnerability factors, things like the presence of concurrent illnesses and disease like diabetes. You think about how those facing economic and social hardship, those that are chronically food insecure, have greater incidence of these types of diseases like diabetes that can make them more susceptible, and those that have access to consistent, higher quality nutrition that may confer more protective factors. So in terms of the actual levels of what we consider safe and unsafe, both of our studies are leveraging what's called Proposition 65, which is a ballot initiative in California, which basically says those in California have the right to know what they're being exposed to, both in their drinking water and in the environment. And they define for a variety of chemicals a no significant risk level, an NSRL, which says that a daily intake of that substance would cause fewer than one additional case of cancer in 100,000 people in those exposed over a 70-year lifetime. So a very low risk. California has some of the most stringent regulations in the country. For our study, we also leveraged on that for the egg study. With lead, we augmented the Prop 65 standard with a monitoring standard from the FDA and the CDC, which basically says how much would an adult or child have to ingest daily to reach a blood lead level. So how much lead is in your blood, at which monitoring is recommended. And how they define that is the blood lead level of the upper 2.5% in the United States. They recommend monitoring. And again, that's a very conservative estimate. At that point, they're just suggesting monitoring, not even medical intervention. Really, the overlying theme here is we want to catch these problems early. For soil, the thresholds that we're using are from the United States EPA, the Environmental Protection Agency, and the California OEHA, the Office of Environmental Health Hazards Assessment. And how they define risk is very similar. What they are defining is a cancer risk of 1 extra case in cancer in 1 million people. So make it even stricter than the Prop 65 levels. So again, the overarching theme with all of this is providing an overestimate of risk, because our goal is to find problems before they become big problems. And with that, I will hand it back over to Vanessa.
Thank you, Todd. So we're now going to describe the background and methods specifically for the produce study and incorporating soil into that, followed by the results. As I was saying at the beginning, the background is that this study began while the fires were still ongoing. We utilized a team of volunteers, mostly from the Master Gardener program of the UC Cooperative Extension, Sonoma County. And by activating that network of people already connected with community gardens and backyard gardens, we were able to get plant samples from 25 different sites across the region and over 200 samples in our freezer. All of these sites were within the area that had a large concentration of smoke, but they were not properties that were directly adjacent to any burned buildings. Our question was, can smoke create contaminants in garden sites? If you are on a property where a building itself burned, you should turn to other local agencies for cleanup suggestions. For our study, we went through 3 distinct phases. In our first phase, we looked at 2 sites and sent in those samples for a broad battering of tests in order to generate some hypotheses. We then sent in another 3 sets of samples, 3 different sites for phase 2, and that's what we'll be reporting on today. In phase 2, we also went back 8 months later to those same sites that we had collected produce from during the fire, and we also collected soil. So during phase 2, the produce and the soil that we're reporting on come from the exact same sites. After we had all of the data from this phase 2, this hypothesis testing phase, we then wanted to look at what are some of the broader contexts of the health concerns during a fire and the protective factors that come from a strong local food system. And that will be the cumulative risk assessment and these community workshops that we're doing now. For phase 1, we did a preliminary analysis based on a meteorological model of where smoke was likely to be depositing. At this point, we did not yet have real-time air pollution monitor results. And so we were relying on a model that used from NOAA, the National Oceanic and Atmospheric Association, that could model for us what the weather was doing that day in order to start to predict where the contaminants from the urban burn area in particular were likely to have settled. And that's what we sent in for our phase 1. From phase 1, we were already starting to see that we had low likelihood of high risks from the produce from these areas, but we wanted to get a clearer idea. And so we went on to phase 2 and sent in more sites. By the time we got to phase 2, we had a more detailed understanding of where the smoke actually was densest during the fire. So we used air pollution monitors from the California Air Resources Board, CARB, in order to understand the sites from our sample that were closest to where the smoke was densest. And so we ended up selecting sites that were at varying distances from the fire and smoke concentrations. So what we found from our second round of testing was a confirmation of our hypothesis. When it comes to the produce, we have a low concern that there are going to be significant health risks emerging from people eating produce that was exposed to smoke during the fire. For instance, none of the produce samples that we tested had any detectable levels of polycyclic aromatic hydrocarbons, PAHs, or polychlorinated biphenyls, PCBs. However, it's important to acknowledge that the lab methods that we were using have a detection limit that is higher than Prop 65's NSRL. What that means is there is still some level of uncertainty about whether or not PAHs or PCBs are a concern at lower levels than we are able to detect. That said, we still had no detections at all. We also had no detections of dioxins and furans in 12 out of the 13 samples. There was one sample with detectable levels, but these levels were still below California's NSRL. Also in 12 out of the 13 samples, produce did not have any of the Proposition 65 regulated heavy metals. In the one sample in which we did find heavy metals, it was only nickel that was found at levels that exceeded Prop 65's NSRL. An important thing to note about this is that the nickel NSRL was created and derived from studies of toxicity of nickel refinery dust from processes for creating metal products. And so it is not clear if that same type of nickel compound will have the same toxicity as what we found in our soil. Nickel toxicity varies by compound, and some nickel is even nutritionally beneficial. So in future studies, more research is needed to better understand which nickel compound is present in the particular sample. But we did not have that. What is important is that it was only one sample out of 13 that had any nickel levels above what we know to be potentially dangerous. And then the bottom line, because these are the most important heavy metals when it comes to public health, no samples had detectable levels of lead, arsenic, mercury, or chromium, which were some of the highest concerns in the community in 2017. So our overall impression is that produce is not significantly, the health impact of eating produce from gardens that were exposed to smoke is overall very low. We also did soil samples on those same sites, and we found a similar story. There is also a low concern from these sites. However, we advocate that more testing be done in Santa Rosa in particular. In every sample that we sent in, heavy metal soil concentrations were below Sonoma County's post-fire cleanup goals across the board, every heavy metal, every site. None of the soils had any detectable PCBs, and we are very certain that our limits of detection were below NSRL. So we don't have the same uncertainty here as we did in the produce. However, the site closest to the Santa Rosa fires had the highest levels of dioxins and furans. And these levels at that one site were exceeding EPA and OEHA soil screening levels. It's important to note that we can't confirm from our particular method whether these contaminants were present from before the fire or are a result of the fire. Because this was the only site that we sent in from Santa Rosa, it could either be that this particular site just happened to have higher levels of dioxin due to things such as bringing in soil from other places, or local contamination that had happened previously in the site history. Or what we could be seeing is truly the result of the smoke contamination from the urban wildfires. Unfortunately, we cannot say that from this study alone, and so it's important that more testing be done in Santa Rosa. And turning it back over to you, Todd, to convey the results from the egg study.
Let's get right into it. So where did we get all these eggs from, and how did we get them? Well, this was a completely voluntary study. We put out a call on various social media outlets, cooperative extension offices, through the UC Davis website right after the 2017 fires, saying, we're doing the study, we want to analyze your eggs, send us what you got. And the response was fabulous. We got samples from 344 residences all throughout the state. And we also collected 2 from commercial poultry facilities. These are indoor type facilities as sort of our control for comparison purposes. So on a map, that's what this looks like here. Now, California is a very hard state to visualize all in one map, but bear with me, we're going to zoom into some more interesting regions here. But what you're seeing, the orange dots are each one of those sites from where we got eggs. The red outline are the wildfires from 2017, the big ones especially in Sonoma, Napa, and down in Ventura. So really the distribution, what you can see is there's concentration of those orange dots from where we got the eggs in both fire affected areas and in areas where high population are, what you would certainly expect. So let's zoom in a little bit on the Sonoma, Napa area. And this is what we see. So now you can see the outlines of the wildfires much better. You've got the Tubbs, the Nuns, and the Atlas fires from 2017. And we have 16 samples from Napa. We have 75 from Sonoma. And you might ask, well, how did you get so many from Sonoma? And we actually had a cooperative extension officer who was just fantastic, who really went to bat for us in soliciting and getting samples. In and of itself, a little bit of a selection bias, but one that we're actually happy to have. So like Vanessa was talking about earlier, a lot of these samples are adjacent to, but not on top of the actual fires themselves. If you weren't in the area, you may not know how badly these regions were affected. So if we overlay a satellite image of the smoke, you can see just how affected these sites are that were adjacent to the wildfire perimeters. And this was on day 2 of these large fires. For those that were in the area, you remember just how blanketed you were with smoke and ash. All right, so what did we find? And the answer is we found a bit of lead and not much else so far, and that's a little bit of foreshadowing here. So let's take a quick detour and talk about how to interpret lead results. What you're going to see on the next few slides is a legend that looks like this. What this is the mean or the amount of lead in micrograms per an average size egg from each of those backyards. What we want to see is below the FDA child threshold. Remember those thresholds I was talking about that the FDA was suggesting for monitoring purposes. That low threshold for children is at 3 micrograms a day of lead. So what they're saying is we prefer the child not be exposed to any more than 3 micrograms a day. Otherwise, they're recommending monitoring for blood lead levels. For adults, it's about 12. It's actually 12 and a half. It's going to be easier for you to remember 12. So again, the numbers are 3 for child, 12 for adults. And again, what we're looking for are, we want the small green or yellow dots. We don't want the big, scary red and orange dots. So we'll start with that overview again of California, just to get sort of the high level distribution of where the high level lead sites are. And if we were looking for data to suggest a relationship between wildfire and lead in eggs, then what we would expect to see are the big red dots in those wildfire regions, and the dots would be smaller and took the more green type color away. And looking at this, that's not what you see. Again, let's zoom in to that Sonoma Napa area. And what we're seeing is a lot of green dots. If we zoom out just a little bit, we start to incorporate more of those larger, higher content lead. In fact, some of the highest content lead that we actually detected. And so really the question that we have to ask is, assuming all the assumptions that we made for our study are correct, does this data give evidence, lend evidence to a relationship between proximity, closeness to wildfire, and lead content in eggs of backyard poultry? And the answer thus far is no. Well, let's quantify this a bit. So how many of those properties, those 344 properties that we talked about, had a problem? And the way we're going to look at this is something that's called a histogram. So on the bottom here, the x-axis, we have the amount of lead. And remember those FDA thresholds, the child threshold at 3, the adult threshold at about 12. We want to be below those. The bars here, the columns, are the amount, the number of properties that fell into that region that had that amount of lead. And what you want to be, of course, is way down here. You want to have very little lead in your eggs. And what this graph is showing is, fortunately, only 4 exceeded that FDA adult threshold. So 4 out of the 344, just over 1%. We had about 27 or 8% exceed the child threshold. So just for comparison, remember those indoor commercial facilities I talked about? They ended up way down here in this column. There was hardly any lead in their eggs, which is not a surprise. So how about the eggs specifically for Sonoma properties? So we can overlay that. Those highlighted in orange are just those associated with Sonoma County. There were only 3 out of the 75 that exceeded the FDA child threshold. So that's a lower percentage than overall in our study. For Napa, it was a little bit different, although there were still only 3. Now that was out of 15 total. So a higher percentage in Napa. So let's look at it a different way. What if we summarize this by county? Which counties had the biggest problem? In other words, how many in each county exceeded that FDA child threshold? So at the bottom here, we have the counties in descending order. In parentheses is the number of samples from each county, and the percentage of those samples whose average egg content of lead exceeded that FDA child threshold. And let's look for the counties with the closest proximity to wildfire in this study. That would be Napa, that would be Sonoma, and that would be those down south in Ventura. So if we're going to look at this again and ask ourselves, does this provide evidence that there is a relationship between proximity to wildfire and content of lead in backyard poultry? And you'd be hard pressed to say that it does. Now, one thing I want to caution against is looking at this and then assuming, oh my goodness, Alameda and Los Angeles have a tremendous problem. We need to go there and do something. This is not a tremendous number of samples to have 20 or 10 or 12 from a particular region. What we want to do is say, does this provide evidence about proximity to wildfire and lead content? What we're not able to do with this data is say where exactly the problem is without a larger sample size. All right, so what about the other toxins, the other heavy metals? Well, with mercury, only 2 premises out of those 344 had any concern whatsoever. And you would have to eat 2 to 3 eggs daily, every day, for that to be an issue. And that was actually a reproductive concern. And those reproductive thresholds are the lowest of the low. They're actually quite a bit lower than the cancer thresholds. For cadmium, we only had 1 site of concern, and you'd have to eat 3 eggs from that premise daily. Again, that was a reproductive concern, so the lowest of the low thresholds. So how about those persistent organic pollutants we talked about? Well, for that, you're going to have to stay tuned. We are almost done analyzing those results. I spoke with our toxicology PhD student, Claire O'Brien, last week about that, and the last set of samples have now gone into the lab for testing. So we almost have those results. So stay tuned, and we will update you on the website that you found this webinar. All right, so now with that, now we need some context as to how to interpret all that. So for the cumulative risk assessment, I'm going to pass it back over to Vanessa.
Thanks, Todd. So as you can see from the results from both of our studies, already just looking at each of these different things individually, soil, produce, eggs, in all of this, we're finding the overall assessment that there is a low risk, but we know that there's still a great amount of uncertainty in our data. And so we wanted to use a cumulative risk assessment approach to start to get closer to understanding what is the combined impact of all of these different exposures. And then even a step further, how do we then compare that kind of combined impact with what we know are some of the health benefits that can come from things like eating nutritionally dense local produce? So for our cumulative risk assessment, we used this model of trying to look at both chemical and non-chemical exposures, as well as the health hazards and the protective factors, in order to have a more holistic understanding of the big picture of these decisions. Because we know at the end of the day, the question that people keep asking is it okay to eat this food? And in order to answer that, we need to better understand all of the different factors that go into that kind of decision. So the very first step is that we wanted to evaluate all of the different chemical exposures. So if we take every single chemical that we looked at in our study and use an additive approach to combine all of the risks, then what we get is this. We still have an overall low risk. However, if you look at the column that says maximum possible risk, for maximum possible risk, we do find that there is an elevated amount of risk. The maximum possible risk was including all of our uncertainty variables. For all of the different chemicals for which there was any uncertainty, we used the highest value possible, which is the detection limit. So if we were to imagine that every single one of those chemicals that we did not detect, if we were to imagine that they were right there, right below our test's ability to detect them, then this is what that combined result would be. So if the entire population of Sonoma County ate only local produce every day for the rest of their lives, and that produce was contaminated at levels just below our ability to detect, then we could predict that there might be an additional 41 cancer cases per year across Sonoma County's 500,000 person population. This method that we're using provides an extremely high overestimate of risk. This is the worst possible scenario that we could come up with from eating produce with all the different chemicals that we studied. And so one of the utilities of creating that worst case scenario is it also enabled us to then look at the next net cancer risk reduction that would come from eating just the green leafy vegetables themselves. And for this, we used a method that came from another paper by Reese et al. And in this paper, Reese puts forward a method for looking at the impacts of nutrition in produce versus the contaminants that may be present on the produce. And in employing that method, we found that indeed, in our case, there is a much higher benefit from eating the produce than there is from the worst possible case scenario from eating contaminants that were found on the produce in the levels that we detected in our samples from 2017. So what this points us towards is that even with the uncertainty that we have in our study, we can say pretty definitively that when it comes to produce, this is not what you should be worried about. In fact, the nutritional benefits of eating green leafy vegetables, it outweighs the potential for harm from contamination at the levels that we detected. So then the next step that we took was to evaluate chemical mixtures in the soil. So if we do that same thing in the soil, we find an even lower risk. So even in the worst possible risk scenario, we only see a potential for 3 cancer cases per year in addition, if the entire population were exposed to soil contaminated at the levels that we found, and they were exposed every day of their lives. So it's overall, we know that it's a very low risk based on what we found, even with that one site that was at a higher level. For soil, we used a model that came from OEHA, the Office of Environmental Health and Hazard Assessment. And from that model, we also were able to locate the age group that has the greatest contributor to your overall total lifetime cancer risk. And that is ages 0 to 2. Most of that, about 2/3 of the total lifetime cancer risk that we identified, is attributable to exposure to soil that's just during that age group period, from when you're born to about 2 years old. And that comes from a lot of things. That's often infants and toddlers are much more likely to be ingesting the soil itself. So that's putting their hands in the soil and putting it directly into their mouths. This isn't related to dermal contact with the soil. The biggest threat here, and it's not about eating trace contaminants that plants were able to pull up from the soil into their plant bodies. That's far lower. The biggest concern that we have is just direct exposure of the kid to the soil itself and ingesting that soil in through their mouths. So overall, exposure through produce and soil are both very, very low overall. And an additional part of our cumulative risk assessment is that we wanted to better understand where are all the places where people are being exposed to these chemicals and how do they compare. And what we found is that for each of the chemicals that we looked at in our study, they are present in far higher levels in other kinds of food. And so if you are trying to make the choice between eating fresh local produce that was exposed to smoke or other kinds of food, there are other exposures that you need to be aware of. So for instance, dioxins, which we heard a lot of concerns about with produce that's being exposed to the smoke, dioxins are actually far more present in meat, especially fish and dairy. And that's because dioxins bioaccumulate. Like Todd said at the beginning, they're very persistent in the environment. They stay in fatty tissue. And so they build up along the food chain. And animals that are higher in the food chain are going to have higher levels of dioxins. Same is also true with PAHs. PAHs, they don't bioaccumulate, but like Todd said at the beginning, they come from that smoking and drying process, anything combusting. And so actually the highest levels of PAHs in the food system are in barbecue and processed foods. So the smoking and drying process for things like cereals can leave much higher PAH residues than what we're finding in produce exposed to wildfire smoke. PCB is a similar story. They also bioaccumulate, and so they're particularly higher in fish. And also the same with heavy metals. Heavy metals are found in much higher levels in meat and processed foods. All of these are from the FDA's total diet study. So if you're then trying to make the decision of eating local produce versus eating other produce from other produce sources, it's also important to recognize the ways in which you are shifting exposures. So you may be reducing some of your ingestion of contaminants in smoke, but you're increasing your ingestion of other kinds of contaminants. So for instance, BPA is another endocrine disrupting chemical. It's been in the news a lot more frequently these days because it's been found that plastic can linings that contain BPA can leach that chemical into the food that's in their cans. That's just one of the ways BPA gets into the food system. We also know that pesticide residues can contribute to a number of different hormone dysregulating and cancer producing mechanisms in the body. And so The trace contaminants from smoke need to be weighed and thoroughly considered alongside these other kinds of contaminants that come from other parts of the food system. It's important to recognize that in California, if we're thinking just about our concern for air pollution, the areas where most of our produce is grown in the state, where a lot of the lettuce that is exported to the entire world is grown in areas that have really high levels of air pollution. But this kind of air pollution is particularly worrisome because these are places with high levels of air pollution on a chronic everyday basis. Every day over the life course of a particular plant, they are being exposed to high levels of pollution. Whereas like in our situation with the wildfires in Northern California, we're dealing with an acute exposure or a subacute where the produce is exposed to that smoke for a shorter duration. The other thing that we can recognize and acknowledge from this map is understanding that in Sonoma County, we have on a chronic daily basis some of the best air in the country. And some of the best air in the state on a chronic daily basis. And that's not only of importance for the food, but it also means that our bodies are less subjected to these chemicals by breathing every day. And so we have more protective factors in our body to be able to handle this kind of emergency event when it does happen. Which brings us to the social determinants of health. Over the past couple decades, public health researchers have increasingly moved away from just trying to look at the individual causes of disease, age, sex, constitutional factors, and move more towards the larger social, economic, cultural, and environmental conditions that impact health and wellness. From the Population Health Institute, we actually have some number breakdowns that help us better understand the varying contributions of these different kinds of social and economic factors. So from their county health rankings model, we see that physical environment, the actual chemicals, like the things that we're talking about that come from environmental quality and built environment, that constitutes only about 10% of predictive value of what's going to make someone sick or well. The other things that constitute a far higher percentage are things like access to healthcare and the quality of that healthcare. Health behaviors. Is someone a habitual smoker? Do you have access to nutritionally rich produce? Other kinds of lifestyle and behaviors. And then about 40%, almost half, are these socioeconomic factors. Access to education, employment, a good living income, having family and social support, and a sense of community safety. What's important to understand is that it's not that chemicals are not important. Everyone is exposed to these based on where they live. They'll be exposed at higher or lower levels. But the question is, after you've been exposed, who is then going to get sick? Who becomes ill? Who gets cancer? Who gets asthma after being exposed to these kinds of chemicals? And that's where this predictive model really comes in. People who have less access to education and employment, who have less social support, are going to bear the physiological brunt of that pollution at a much higher level. So taking the social determinants of a health perspective into account, we can also just turn our attention to looking at something like cardiorespiratory impacts. The number one thing following a wildfire, the top health concern, are impacts to the heart and lungs. And we can see these social determinants of health playing out even just on this heart and lungs level. Really well documented, there are a lot of studies. So for instance, we can see that if you are of a lower socioeconomic status, such as income, education, and race, you have a much higher risk of ending up in an emergency room after a wildfire has begun. You're also much more likely to end up in an emergency room experiencing like acute cardiorespiratory impacts if you have diet-related illnesses such as diabetes. And you're also much more likely to develop asthma from exposure to air pollutants, when you live in areas with higher levels of community violence. If you have pre-existing cardio and respiratory health conditions, then those pre-existing conditions make you more vulnerable to wildfire smoke when it happens. If you're pregnant, there are higher risks to you and your developing fetus, as well as to young children are much more likely to be impacted by smoke because of the critical points of development that their bodies are going through. So these are just a snapshot of the many different ways that subpopulations of our community can be more highly impacted by air pollution. As we're getting towards the end in our conclusions, the zoom out also helps us zoom out to the big picture of the health benefits of what we're all doing by creating a strong, local, sustainable food system. So life is so much brighter when we focus on what truly matters. And the work that local farmers and community gardeners are doing every day is creating the spaces and resources that help community members build their resilience and build those protective factors that reduce their chances of harm when these kinds of disasters occur. So as I mentioned at the beginning, I came into this project because I was working with a local food distribution system that was able to provide emergency shelters and kitchens, people that had just been displaced, that were just subjected to some of the highest levels of pollutants, to be able to provide them with fresh, nutritionally dense produce immediately after that disaster by harnessing all of the networks of local food growers to provide their produce at the height of the growing and harvesting season, to provide that directly to people in need. And it's not just the nutrition in the produce. We also know from studies that look at stress and the health impacts of stress that one of the biggest predictors of what makes a stressful event toxic in the body and leads to those health impacts of stress, one of the biggest predictors is knowing that you have a supportive community that will help you see it through. So these are some pictures from Bayer Farm, a farm in Sonoma County that became a hub during the wildfires for people to share information, give masks, do workshops. They were serving 3 meals a day. So for people in the community who did not feel safe in the shelters for any variety of reasons, many of them would stay in the living rooms and extra bedrooms and any sleeping surface that was possible in this low-income, mostly Hispanic neighborhood near Santa Rosa. And so being able to have a community turnout to feed everyone was a huge relief off of the people who were hosting people in their own homes. And it provided that sense of community and to know that your neighbors, your community members are there to provide places of joy and connectedness and resources. It's hard to measure these things with as much detail as we can chemical concentrations in the blood, but we have research from decades of psychological and public health studies that show that it is as much, if not more important than the amount of chemicals that someone is exposed to in terms of predicting whether or not those contaminants actually impact the body and produce illness. So, all of that said, lots of results, produce study, egg study, cumulative impacts. It might all be swirling around, and you just tuned into this webinar to find a quick yes or no, is it safe to eat the produce? Well, here's our answer. Of all the things to be concerned about following a wildfire, produce is a low concern. Our results from our study show a low concern of health impacts from ingesting the produce that was exposed to the wildfire smoke in Santa Rosa in 2017. In this instance, this particular wildfire event, these particular sites and samples, the potential cancer risk is outweighed by the cancer risk reduction from the nutritional value of eating produce. You can make your own risk decisions during an emergency by considering your proximity to fire and any vulnerabilities that you might have. So when we take all of these different things into perspective and we look at this big picture, these are the main messages that we think are the most important to share. Number one is protect your lungs. A lot of people are calling into us asking about is it safe to eat the produce? And we're saying the number one thing is, if you are out in your garden at all, make sure that you're wearing a properly fitting respirator that is an N95 or higher that can protect your lungs from inhaling the smoke, because that has the most severe health risks. We also know from our study that nutrition builds resilience and that overall there's a low risk of harm from produce exposed to the smoke. If you are going to eat the produce from your garden for that nutritional benefit, especially if there is not a lot of other healthy options available, the best way you can protect yourself is from removing the outer leaves or peel and washing it if you see any ash whatsoever. Just wash produce with running water. We're also suggesting that people take extra precautions if they are among a vulnerable community: children, elders, people with respiratory and heart disease. It's important to go to even further measures to stay inside, protect your lungs, as well as to do the things that will boost your immune system, such as eating healthy local produce. When you're getting calls at your local county, when your local community garden is getting phone calls and requests from neighbors to know if it's okay to eat their produce, these are the main messages that are really important to get out into the community when a wildfire is happening. So that's the bottom line. This is a really site-specific, time-specific study. And so we encourage more people to be looking into this in the future to see if you find similar results. I'm going to turn it back over now to Todd to give us the final assessment from the egg study.
All right, so same question. Is it safe to eat the eggs? And what we found is that a low percentage of eggs from backyard poultry could contribute to a level of exposure requiring monitoring of blood lead levels, especially that of children. Now, it's important to note that as of today, that concern is not a wildfire-specific concern. It's a general concern. We're not sure what the factors are that are contributing to that. In fact, the next part of our study is focused on assessing risk factors other than wildfire that may be the cause for lead in eggs of backyard poultry. So a question that you might be having is, well, statistics and averages and things are great, but how can I determine my risk, my family's risk from eggs in backyard poultry? Well, first you have to know what's in them. If you were part of our study and they tested high, get them retested. If you weren't part of our study, then get them tested. And you do that at the California Animal Health and Food Safety Lab. We're going to have links both at the end of this presentation and on the same website that you found this presentation to exactly how to do that. And then the other consideration is knowing the frequency of your exposure. In other words, how many eggs and how often are you eating them? So you put those two things together and that tells you what is the risk from eating eggs of backyard poultry, specifically for something like lead. So then that brings us to how to reduce your risk overall. And for this, I'm going to turn it over to Rob Benetton to guide you through that.
So how to reduce risk? At the end of the day, a lot of these considerations are about managing risk for, say, food, family, and farm, and ultimately community. So one can manage risk by doing the basics when wildfire is nearby. If you have backyard chickens or if you grow crops. So some of the basic protocols that you can do on a daily basis at your farm or garden site are the following. Wash your hands before eating and handling food. Wash your produce before eating, storing, and cooking. Consider using white vinegar to help uplift some of the soil particles off of the produce. Keep the outdoors outdoors. Think about installing a boot brush outside of your home before coming in so that you can ultimately brush your boots and get some of those soil particles off of them before you go inside, or even taking off your shoes and boots altogether. Know what you're being exposed to in the soil, water, possibly in paint if your home is pre-1979, and do something about it. Get your soil tested. Test, test, test. Don't guess, but test. Protect your lungs. Do everything on the previous slide twice at the very least. Contain your soil. Build upward instead of digging in, especially if there are known contaminants once you've gotten your test results back. Consider mulching to minimize soil upsplash of particles in particular. Think about drip irrigation, subsurface irrigation, again, to minimize upsplash, but also conserve water. Add compost and clean soil to your raised beds. Think about maybe even having a landscape fabric in between the local soil and your imported soil and or compost. Regularly amend your soil to dilute potential low concentrations of contaminants if found as a result of your tests. Know what you're being exposed to. This becomes a repetitive theme. Again, don't guess, test. Everybody repeat after me. Don't guess, test. Use, in terms of backyard eggs, there are also some additional measures one can take to reduce risk as well. Use feeders for all types of feed, including scraps. Limit contact of hens with high-risk areas of the yard. So when you did your soil sample test, you also ought to think about mapping where you took your samples from so that when you get your test results back, you also know where exactly those specific results refer to, so that therefore you can limit the exposure of your hens in those particular yard spaces if particular yard spaces or farm spaces were found to be contaminated. Think about supplementing your feed with a calcium source, but not too much. And then it is possible to actually apply calcium, and that can affect the health of the chickens ultimately. That is why one doesn't want to over-apply. And then know what you're being exposed to. Again, don't forget to get your soil tested. Very, very important. And then I'm going to pass the microphone back to Julia Van Sol and Kim to wrap us up.
Thank you, Rob. To close out today's webinar, we want to reiterate a few points. First, that this is an emerging area of research, and it's particularly timing given the increasing frequency and severity of wildfires. But we want to underscore that each wildfire is unique. Our study looked at wildfires that were urban in nature. More traditional wildfires may carry little risk of contamination to produce and eggs. However, more urban wildfires may carry a greater risk. And as researchers increase the understanding of what contaminants to look at, where and when, what we choose to look at may evolve with this emerging research. And for that reason, we encourage other communities to do their own further research that's site-specific to their location. And in doing so, we hope that you consider UC Cooperative Extension as a resource for these university community partnerships. We'd also like to share resources where you can stay up to date on our study's ongoing findings and to get information on how to test your soil and eggs for potential contaminants. We also have a Google group where you can join to receive ongoing updates. And in closing, we want to thank all those who have participated by sending in their chicken eggs, opening their farms and gardens for produce samples, volunteering their time to collect soil samples, or donating to this project. We also want to thank the Bay Area Air Quality Management District, UC Agriculture and Natural Resources, the USDA NIFA, and Sonoma County residents for funding this project. I also want to close by thanking each of our presenters today, Vanessa Raditz, Todd Kelman, and Rob Benetton. Thank you so much for your time and for your interest in this important topic.